So, as you said, I'm going to talk about the biggest hot strip mill in Latin America and the ramp up because I was part of that as a very young professional. So, in the beginning, I would like to talk you about the metallurgical tetrahedron before to go to the um, to the hot strip mill. So, I'm going to talk you about this a little bit. Um, this tetrahedron tells us the relationship between four parameters that that give us the performance of the material. First is the chemical composition. Then is the processing, the mechanical properties, and the microstructure. Those four relation, the relation of those four is the performance that we have in the material. In this case, the steel. So now the new hot strip mill in Pesquería. Pesquería is the name of the plant where is located this hot strip mill. Well, in the beginning, I would like to tell you some general aspects about this. Ternium invests a total of $1.14 billion in this new hot strip mill. Our capacity is 4.4 million tons per year, and some of the market segments we are targeting with this hot strip mill is the automotive, the energy, infrastructure and transport, heavy equipment, and construction. These segments were asking us for bigger coils, more thicker coils, and more heavy coils. So with this new hot strip mill, we can do that. We also have the ability now to produce a whole new set of steel grades as the high strength steels and the advanced high strength steels up to 1.2 gigapascals in yield strength. And the dimensional range of this new hot strip mill is for materials really thick and really thin, from 1.2 to 25 millimeters. That's 1 inch, and also really width. It's almost 2 meters. So I would also like to talk to you about the process of the hot strip mill, starting in the slab jar. This is an actual footage from the slab jar in this new strip mill. As you can see, these are the slabs that are coming by train, and all of these cranes are automatized. You're not gonna see any operator in those cranes. This is also a good point in safety for us because everything is automatized from the slab jar to the cooling bay. We also have an advancement. This is the slab sizing press. This is in the beginning of the mill after the slab reheating furnaces. The slab jar is just the slab sizing press, is just a punch in the slab, so we can have more availability of slabs, and we can produce different widths with the same slabs. So this is new in the Ternium family. Then I would like to talk to you about the roughing mills. We have two of them, and these mills, the difference between this mill and other mills that we have in Ternium is that we have two rough mills. This is because we need to achieve a bigger reduction in thickness, so we can get to the final thickness that sometimes is 1.2 millimeters. And this is a footage of how the slab is getting milled in the roughing mill. Then we have a transfer table. In the conventional mills, we have a coiler between the roughing mill and the tandem mill. This was not very good for the superficial quality, and the difference here in MC4 Pesquería. MC4 stands for Molino Caliente. That's hot mill in Spanish. We have the transfer table. It's a table where we do not coil the transfer bar. We just cover it with this cover, maintain the temperature. between the rolling mills and the tandem mill. Then the tandem mill, it's 7 castles vertical, and the milling temperatures are from 1000 Celsius, and the finish temperature can vary, and that's because we need to produce different microstructures, and that depends on the processing temperature. And we have here a video of how is the hot mill process. That's that's a transfer bar, and it's going into the tandem mill. So in general aspects, that's how it looks, the hot strip mill. And this is what is happening inside the steel. We first have a microstructure that comes from the rolling mills. This is austenitic because of the temperatures that it's coming, around 1000 degrees Celsius. And we have here 2 kinds of recrystallization, dynamic and static. Dynamic is when the material is still getting milled, when it's still between the rollings, and the static recrystallization is after the formation. And if we vary the chemical composition, one of the points that I told you about first, we can put certain chemical elements like niobium, vanadium, and another alloys in the grain border, so we can control how much is going to grow that grain. And if we control the size of the grain, we also control the mechanical properties. So that here plays 2 things: the chemical composition and the processing. How are we going to process it, and how many elements or alloy elements are there, so we can have the microstructure. And then we have 3 points of the metallurgical tetrahedron. Then we have the round out table. That's where we have like the magic of the steel, because we can control here the temperatures that are going, the rating temperatures and the temperatures that we are going to reach in this round out table, and we control which curves in the CCT diagram we want to touch, so we can control what components of the steel we would like to have in the steel, right? Like austenite, perlite, martensite, depends on the steel we are producing. And then the coilers. The coilers, we have 2 in this mill, and this is an actual footage of the coilers. The coilers are right here, and then, as I told you, everything is automatized. So these little cars come along and then transport the coils to the slab jar. And we have here a virtual tour to the mill. First, there is the roping mill, and there is the finish mill. The runout table and the coilers. And then that's the slab jar. Well, that was the virtual tour. I will also like to tell you about my experience. It's not going to be in a presentation per se. It's going to be more vivencial talk, because I would like to tell you how was for me to be a young professional in the steel industry and be in the ramp up of the biggest hot strip mill in America Latina, right? Because I was not even graduated when I got into the steel industry, and then I was just put in this team where I was surrounded by engineers who had a lot of experience, who were very prepared, and I was the youngest and the most new engineer there. But the trust that the company gives you do your job and what they're expecting you to do is what really matters. And the trust that the company gives you as a young professional is also really important because is what got me where I'm now. So for all the young professionals, first you have to believe in yourself and that you can do the things that you want and the things that you are proposing yourself to do, and then the company is going to give you that trust. A lot of companies I know that do that. They trust in the young professionals a lot, and they treat you like any other worker, any other engineer who has much more experience than you. So that's it. It's a really quick presentation about the MC4 and the experience I have as a young professional. If you have any questions, please let me know.
Grecia, thank you so much for your presentation. It was very complete, and also for sharing your personal experience being part of this massive and important project. We do have questions from one of our panelists as well. And let me read the question. If you want to explain a little bit further, what is the slab press process and how it works, and how does it help to improve productivity in the rolling mill?
Okay. I think you're referring to slab sizing press. This video that I had.
Right.
We buy the slabs from a lot of other companies, mainly from our own company in Brazil. Ternium Brazil gives us a lot of these slabs. Almost 80% of them are from there, but the melt shop has not always the capability to produce slabs in a big range of widths, and the requirements of our clients sometimes are very specific, and we need to sizing press these slabs. We can come from a slab that has a width established, but we may need a lot of products in a width range that we cannot produce with this slab. So this slab sizing press gives us the ability to reduce the width, so we can have more options to the final width of the coils, and improves productivity because of that, because we do not need to wait for the right slab or for the right width, so we can just sizing press it. And also sometimes when the width is bigger than the client requires, we go through a process that cuts the edges and leaves it in the required width, but that generates a loss in that quantity that was coded. So productivity is improved by this equipment.
Okay, thank you. And another question as well from Mohammed is why 3 down coilers?
Sorry, can you repeat that question?
Yes. Why do you have 3 down coilers?
We have only 2 coilers. We have the capability to have another one, the third coiler, but that is a project to the future when we can produce even more than 4.5 million tons per year. And that's the 2 coilers is also to improve productivity, because we can have from 2 to 3 or 4 slabs being produced. One can be going out of the reheating furnaces. Another one can be between the rolling mills, another in the transfer table because we can maintain there the slabs, sorry, the transfer bar at the correct temperature, and the other one can be being laminated in the tandem mill. So to improve productivity, we have two coilers. When one of the coils is being, when one of the strip mills is, the strip sheet is being coiled, the other can be also starting to enter the tandem mill and then being coiled. So it's for productivity.
Okay, thank you. It's asking us if it's a dual strand mill, what you have.
A dual what, sorry?
Dual strand mill.
Dual strand, you referring to, well, no, this is a conventional strip mill.
Okay, only one.
Yes.
We have another question from Saul Centeno. Thanks you for sharing. And he asked, what happens if the client wants a different austenitic grain than the process original gives? If the client wants a different austenitic grains other than the process originally gives, do you process it again for heat treatment, or you just give them standardized properties?
If you refer to the grain size, we can play with that in the round out table with the coiling, the cooling rate and the temperatures. We can have a bigger or a smaller grain, but in most cases we look for a small grain so the properties are homogeneous all through the coil. But if you refer to, I don't know, to another structure, we can also play with the temperatures and the water that is coming out from the round out table, so we can give you another components in the steel, not just austenite.
Okay, thank you.